So, children, we are doing how to separate the components of a mixture. We have seen so many techniques, so many methods, so many processes by which we can separate the components of a mixture. Now, we have to discuss how to get the crystals of pure copper sulphate and how to remove the impurities. Impurities and copper sulphate means it is a mixture. How we have to remove those impurities from copper sulphate. Crystal of copper sulphate, they contain impurities and we have to remove those impurities, or you can say that by this way you can separate the components of a mixture. So, the method which we utilize here, that is crystallization. Crystallization. Crystallization, as the name only suggests, that we will first form some crystals and these crystals will separate out. What are crystals, children? Crystals are the substances which have definite geometrical shape, as you can see in case of sugar. Day to day what we are using is sugar. In our daily experience we are using sugar. All the particles of sugar, they are having definite shape. Even salt though by taking salt in our hand you cannot differentiate the shapes, you cannot say that they are crystalline, but if you will see them under microscope, then you will see that they have some definite geometrical shape. So, this is about the crystals. In the same way, copper sulphate, it is also having some definite shape. The particle of copper sulphate, they have some definite geometrical shape, and that is the reason they are called as crystals. So, how to get the crystals in from copper sulphate? So, for this the process used is crystallization, and for this what you will do, you will take 5 grams or 10 grams of copper sulphate crystals in a beaker and you will add water to it. So, this is a beaker and in this beaker you will take, copper sulphate is blue in color and this is impure, it contains impurity. So, and these are they have some definite geometrical shape, so we say that they are crystals. So, you will take a beaker and in that beaker you will take copper sulphate 10 grams or 5 grams and to this you will add water. How much water you will add? You will add that much amount of water which is sufficient, just sufficient to dissolve this copper sulphate crystals. Or you can say we will take very less amount of water such that only these copper sulphate crystals, they will get dissolved. Now you have copper sulphate solution. Copper sulphate solution. This copper sulphate solution, what you will do? You will filter it. You will take a funnel and in this funnel you will put a filter paper, cone of filter paper. This is filter paper. You will take a filter paper and make a cone of it and you will put it in this funnel. This is the funnel. Now, this solution which you have made here of copper sulphate, you will pour on this. What will happen? all the impurities which are present here, they will come on this filter paper. Impurities will come on the filter paper, and the copper sulfate solution will trickle down, and here you can have some vessel to collect. This is copper sulfate solution. Now this copper sulfate solution, you will keep it open, and you will see that when you will keep it open for evaporation, then after some time you will see that the crystals of copper sulfate are formed. Again you will filter the crystals of copper sulfate, whatever is left down, that is filtrate, and the copper sulfate crystals, they will be lying on the filter paper, right. So, and where the impurities have gone? Impurities we have separated here only by filtering through the filter paper, right. So, again we will revise what you will do in crystallization. You have impure sample of copper sulfate. Copper sulfate crystals, they are having a lump of copper sulfate you will take, in that impurities are present. You will take 5 or 10 grams, it is your choice. Now, you will dissolve them in water, and how much water you will take? You will take as much such that it only dissolves copper sulfate crystals. This will be a saturated solution. Now, you will pour this solution on a filter paper. Filter paper where you will keep? You will keep in funnel. Now, when you will pour this solution on filter paper, then you will observe that the impurities will be left on the filter paper, and this solution, copper sulfate solution, it will come down in a beaker or in a container. Now, this copper sulfate solution, this is a saturated solution. Saturated means we have already done saturation, unsaturation and supersaturation. Saturation means at a particular temperature, the maximum amount of solute which can be dissolved in a solution or which can be dissolved in a solvent, right. So, that is called as saturated solution. So, this is the saturated solution which you have got here. Now, you will leave it open. When you will leave it open, then what will happen? That the liquid, it will go away into the air, it will get evaporated, and you will be left with crystals, and still whatever liquid is left, that you will separate by the filter paper. Again you will filter the solution, and you will get crystals of pure crystals of copper sulfate, and in this way we can separate the impurities from copper sulfate. So, this is one of the methods to separate the components of mixture. Now, the last topic in your this chapter, it is one more thing I will like to tell you children, that there are some advantages of crystallization over evaporation. Advantages of this is crystallization, and evaporation we have already seen that first method which we have done, just we leave it open and heat it. The liquid goes into the air and solid is left behind. In that process, what happens in evaporation, though by this method we can separate the components of mixture, but still we see that some of the impurities, they are left along with the solute on the china glass or watch glass. And in crystallization, whatever impurity is there, it is separated by filtration. Here we do not do filtration in evaporation. So what happens? Some of the impurities are still left in the solute or in one of the component of the mixture. So this is one of the advantage of crystallization over evaporation. And one more advantage, that in evaporation, what do? We heat. Sometimes the, you can say, substance, it decomposes because of by heating. When we heat, then sometimes the substance, it gets decomposed. Instead of separation, we get the components of the substance. But in case of crystallization, what we are doing is, we are just getting the, we will leave this solution for some hours, and after some hours we will see that crystals are formed. So here in this case, decomposition does not takes place. So these are the two advantages of crystallization over evaporation. One is that in case of crystallization, the substance does not decompose, but in case of evaporation, because we heat, so the substance may decompose. Second, in crystallization, we remove all the impurities by filtering. In evaporation, what we are doing is, we are evaporating the solvent and we are left with the solute. So in this solute, some of the impurities may be present, right? So these are few methods of separation of the components of the mixture. Now last topic is purification of water. Purification of drinking water. The water which we use for drinking, it is purified how? The water which we get every day in our tap, that is purified how? In the overhead tank, from overhead tank we get the water, but in overhead tank, how do the water, from where this water comes? Usually we get water either from river or from lake, but that river water and lake water, it is not pure. So that is first purified and then it is you can say stored in the overhead tank, and from that overhead tank we get the water which we use for the daily purpose. So this is the source of water. What are the source of water? River and lakes. So this is the reservoir in which water is there. This is water and this is reservoir where we store the water. Now this water, it comes out, and this water which we take from a river or lakes, what are the impurities present in this water? Usually the impurities which are present, they are suspended soil particles, then colloidal clay is there, then bacteria is also there, harmful bacteria are also there, right? Harmful bacteria. So some muddy particles which are suspended. Suspension we have done, colloids we have done, true solution we have done, right. So, some suspended muddy particles or soil particles, they are present here. Then some colloidal clay particles are present there, and some harmful bacteria are also there. So, first we have to remove all these things from this water, and then it is eligible for drinking, then you can drink. So, this is the reservoir where water is collected, and this reservoir, from here the water comes into the tank, and this tank, it is called as sedimentation tank. Sedimentation means you will allow the water to for some time, for some hours you will allow this water to, you will leave it undisturbed. So, what will happen? All the suspended soil particles, they will come down at the bottom. Suspended, this is muddy water, so all the suspended particles, they will come down and they will settle down. These are what? These are soil or mud, soil particles, or they are mud. Then this water, it is then it goes into another tank, so suspended particles we remove here, and this is called as sedimentation tank. In this, water is allowed for some time, for few hours, and all the muddy particles, they settle down at the bottom, and this water now we take it in the another tank, and this is called as loading. Here what is done, some alum particles, water is treated with alum. Here we are saying that suspended impurities, they are separated by sedimentation. Now we have colloids, and we know that colloids are charged. Colloidal particles, they are charged, they are negatively charged, and these alum particles, they are positively charged particles. So, what happens? These alum particles, they will combine with these colloidal particles which are negatively charged. We are doing purification of drinking water. The drinking water which we get, the sources are rivers and lakes, and this water, it contains suspended soil particles, colloidal clay particles, then harmful bacteria also, right. So, we have done that. The soil or suspended particles, they are separated by sedimentation. Sedimentation means the water is allowed for some time undisturbed, it is allowed to stay for some few hours, and all the soil or mud particles, they settle down at the bottom. Now, this water, it comes in a loading tank, and this is called as loading, and here this water, it is treated with alum. What this alum, it is, when it gets dissolved in water, it forms positive ions, and these colloidal particles which are present here in water, these are negatively charged. So, positively and negatively, that is alum and colloidal particles, they react together, they neutralize, and this, in this way they load. Why it is called as loading? Because this alum, it loads on themselves the colloidal particle, and after loading it settles down at the bottom. This is also called as coagulation. coagulation, right. So, this is, in this way loading is done, or you can say that colloidal particles, they are removed by alum in this loading process. Now, this water, now it is taken out and it goes into another tank, and this tank, in this tank filtration is being done. In this tank filtration, water is being filtered. Here filtration is done. This water, it comes out from here and it enters from here. This is filtration tank. In this filtration tank, there are present 3 different kinds of this is coarse gravel stone particles. Then comes in the middle, at the bottom there is coarse gravel, in the middle it is smaller, that is fine gravel. And at the top there is very fine sand particle. Fine sand particles. And then there is water, right. So, here in this filtration tank, what happens, the water which comes from the loading tank, it has to undergo 3 layers. The bottommost layer, it is of coarse gravel means the bigger particles of stone, and next middle part fine gravel, smaller particles of sand, and still at the top there is very fine sand particle. So, it has to go through these 3 layers, and now this water which comes up, it is free from clay, mud, impurities, all the impurities, they go, means first we have separated some of the muddy particles by sedimentation, then this colloidal particles we have separated by alum or loading or coagulation, and next the filtration is being done. Filtration also done by 3 layers, that is coarse gravel, fine gravel and fine sand particles. Now, this water which comes out here, still it has bacteria. So, what is being done, that this water, it is now treated with chlorine. There is a chlorination tank, this is which contains chlorine, and this removes all the bacteria, and now this water, it is fit for drinking. Right. So, this is chlorination tank. This is chlorination tank, right. So, again we will revise that how the drinking water is being purified. The source is river water, lakes, in lake also water is there, but this contains suspended soil particle, colloidal clay particle and harmful bacteria. First, from the reservoir, the water comes in the sedimentation tank. Here it is allowed for some time undisturbed. So, all the soil particles or clay, this mud particles, they settle down at the bottom. Now, this water, it is passed next to the loading tank. In this loading tank, water is treated with alum. This alum, they are positively charged particles, and in water there are colloidal particles which are negatively charged. Positive and negative neutralizes. Here all the neutralized particles, they settle down at the bottom, and this water, it is now passed through the filtration or filter tank. In this filter tank there are 3 layers of, first layer it is of bigger particles of stone, or you can say coarse gravel, then small particles, they are fine gravel, and uppermost layer it is of very fine sand particles. Now, after filtration, this water, it comes up, and then bacteria, harmful bacteria which are present in the water, they are removed by treating this water with chlorine, and this is chlorination tank. Now, this water which comes out of this chlorination tank, it is pure for drinking, it is fit for drinking. So, in this way we remove all the impurities present in the water. Now, so we are done with the chapter, children. Now, we have to discuss some of the question answers. Now, question number 19. Question number 19. What is a pure substance? Till 18 we are done. Now, we have to discuss question number 19.